Okay, here in example 3, we're going to graph this function not using the RATEY method per se, but really just using a lot of the things that the RATEY method entails. And so you can consider this to be sort of like a preview example of what we're going to do towards the end of the notes. And so you can see here that I've given you a function. It's a rational function. I have gone ahead and factored everything for you. And the first thing that I want you to notice is that the numerator and denominator have a common factor. And so therefore, the x minus 3's are going to cancel. Now from our discussion earlier in section 2.6, from our other set of notes, we know that if something cancels, we have a hole. And that hole in this particular case is going to occur at 3 for an x coordinate because we crossed out the factor x minus 3. And then to find the y coordinate, I'm just going to write the simplified version of this and then plug in x is equal to 3 in order to get the y coordinate. So if I just do some scratch work over here on the side, 2 times 3 plus 3 divided by 2 times 3 minus 5. In the numerator, that's going to be 2 times 6, which is 12. And in the denominator, 6 minus 5 is 1. And so my hole is going to be at 312. And so letter E, when it says graph the function and any additional points as needed, I'm going to go ahead and put that point on the graph right here at 312. And I know that the graph is going to have to go through that particular point. Okay, so now we're ready to start answering these questions in order to see if we can graph this. So letter A, find the end behavior. So just as a reminder, or maybe this is the first time you're hearing this, and that's okay. End behavior just means what is the horizontal asymptote or slant asymptote. And most of the time, if not all the time, finding the end behavior is more easily done looking at the original version of the function. So if I look at the unfactored version here, and I just think, where is the biggest degree? Well, the degrees are the same in the numerator and the denominator. We have an x squared in the numerator and x squared in the denominator. So I'm going to have a horizontal asymptote, and it's going to be at y equals 2 divided by 2, which is going to give me 1, and that's because of Eats DC. And so here at y equals 1, I'm going to draw a horizontal asymptote at y equals 1. Okay, letter B, find any vertical asymptotes. So I know that vertical asymptotes occur when the denominator is equal to 0 after I have factored and canceled. And so if you look at the denominator that's left, 2x minus 5, if I set that equal to 0 and solve, I'm going to get x is equal to 5 halves, or 2.5. And so I'm going to have a vertical asymptote, and I'm going to try to do this as best I can at 2.5. It's going to be a little difficult, but there it is. X is equal to 5 halves is my vertical asymptote. For letter C, find the X-Intercept. Another way to say that is find the roots. And remember from earlier in these notes, our discussion, X-intercepts or roots come from when the numerator is equal to 0. And so therefore we're going to have an X-intercept written as an ordered pair at negative 3, 0. And that's because this numerator equals to 0 whenever x is negative 3. And so at negative 3, 0, I'm going to put an X-intercept right here. Hopefully you can see that point right there at negative 3, 0. Okay, the y-intercept, again, is usually more easily found looking at the original version of the function, because remember, all we have to do is plug in 0 for the x's, which basically just means to look at the constant terms. And so the y-intercept here is going to be 0 and negative 18 over 15, which is going to reduce to negative 6 fifths. And so negative 6 fifths is going to be a little smaller than negative 1. And so I'm going to have that y-intercept right here. And there's that x-intercept that I plotted earlier. And so now I have enough pieces to this puzzle to be able to graph this thing. And so I want you to notice that there are basically two different sections to this graph. There is a section that's going to be over here on this side to the left of this vertical asymptote, and there's going to be a section to the right of this vertical asymptote. So I'm going to have to draw in two different sections. Now, this horizontal asymptote basically tells me that I'm either going to graph one of the parts above this horizontal asymptote or below. Not both, because then it wouldn't be a function, but I'm going to have either something up here or something down here. And so the question we have to ask ourselves is, am I going to graph the function up here in the top part or down here in the bottom part? And hopefully you're looking at these points and realizing, okay, well, if I want the graph to go through those 2 points, which I certainly do, I'm going to have to graph down below this horizontal asymptote here. And so what this function is going to do is it's going to come basically underneath this horizontal asymptote, come to that X-intercept, or that root right there, go through it and to the Y-intercept, and then come through that Y-intercept and down the vertical asymptote at x equals 5/2. And there's the first section of my graph. Now, on the other side of the vertical asymptote, I'm going to have a section either here or either here. Now, let me explain why this is going to be incorrect. And I'm going to do this in red, and I need you to hear me very carefully, that what I'm about to draw is not correct, and I'm doing this to basically explain why it's not correct. And so let's just say that this was what it was supposed to look like. Okay, the problem with this is basically twofold. The first problem is that I never went through that hole up there, and I was supposed to do that. Remember, that hole, the function is supposed to not technically go through that hole, but at least approach that hole on both sides. And this graph that I drew in red does not do that. The other problem with this red graph is that it goes through the x-axis at a place where I do not have a root. The only root that I have is -3, 0. I cannot cross through the x-axis anywhere other than -3, 0. And so therefore, this red piece cannot be correct. And so I'm going to just erase it and show you that the graph has to be above that horizontal asymptote. It's got to come through and approach that hole there, and then come through it on the other side, come down and approach my horizontal asymptote like so. And so these are the types of conversations that we're going to have for the remainder of the notes whenever we're graphing rational functions. We're going to have to fill in these gaps and try to figure out, am I above or below? Am I supposed to go through the x-axis there or not? These are the types of questions that we need to get good at asking ourselves.